Thanks.
Yep.
See you guys. Okay. Anybody got any questions before we start? Yeah.
So we have like this new coach meeting 12:45.
You should not be skipping class for even a new coach.
Okay.
Yeah. Your coach should understand that. Otherwise, I want to talk to your new coach if they don't. How about that? I just want to make sure you don't come out as the bad guy. Now that would be university. It doesn't conflict with class, and especially new coach needs to know that. So you just tell him you had class.
Okay.
And if there's any problems, he can talk to me. I doubt he will, but just want you. Students should know that class comes first, always priority. Okay, so chapter 10, here we go. So we're covering chapters 10, 11, and 13 for this week, by the way. So it sounds like a lot, but 13 actually doesn't even have any apply questions. It's a little bit shorter. All the chapters are a little bit shorter. So in terms of content, it's about the same as what a couple chapters would be. So that's part of the reason I designed it that way. So today we're going to talk about land rents. So where does the price of land come from? So does anybody know, do I have any farmers in here? I can't remember if I asked that before. I might not have. Anybody from farming background, grandpa or grandma or anything? Lawson, a little bit of farming. Zeke, a little bit. Jameson, a little bit. Jonathan, you? A little bit? Okay. So do you know, whatever state you're from, what ground is selling for per acre is usually how it's expressed. But Jameson?
Is there like the soil?
Okay, no, but I was wondering like actual dollar value. Do you happen to know? That's why I was asking some of you who might have some personal connections, you might actually know what ground is selling for. Or you might have heard some prices. Jonathan, you, any idea on the price? Okay, so
No
then,
idea.
okay, so then let me roll back to Jameson. What are you thinking the value comes from?
With the soil?
Okay, so soil conditions, right, would be important. Why?
Like if it's a farmer, if they can actually like farm, or if it's like a school, if they can do like foundation on it.
Okay, yeah, so that would be for building, right? So soil condition could be important part, basically how fertile the ground is. So some ground is really high in nutrients, that's black soil or something, and so you might be able to get 350 bushels an acre if you planted corn in it. And if you go to Missouri somewhere and plant in the sand, or go down to Oklahoma or Texas, you might get 50 bushels an acre, right? Because the nutrients aren't there in terms of how productive it is. So our farmer is a profit maximizer. And so if you've got ground that can crank out more bushels per acre, it's worth more, right? I mean, for the same amount of effort, the ground itself is going to contribute to higher productivity, give you higher production levels. So soil conditions good. And then you brought up building, which would be another thing if we got into ground that is real rocky. It might be harder to build foundations or something. So if you're a real estate developer, it might be more costly, and that would cause you to lower the value of the ground, because I might buy your ground, but then I have to spend extra money to be able to put in a foundation in your ground as opposed to the ground 100 miles away. And so the value of the land is in large part going to be dictated by the soil conditions. What else would be in spatial economics class something? So soil condition might be one thing.
Location.
Location, 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 right? So how close are you to the deep processing plant, of course, and stuff like that. Can you think of other things that might drive land prices?
How much money it'll produce?
What's that?
How much money it'll produce over time, depending on what you're doing.
Okay, and which would be kind of interrelated to some of this stuff, right? In terms of money, or what were you thinking? Money produce? How would that?
Like a revenue stream. Like
Okay.
how you would use the land as a revenue stream into making other money.
And are you renting it out to somebody else, or?
It depends. If you buy, like if you were out in the market looking for land and you were to purchase it, you need to know how you're supposed to develop the land, because no one wants to pay for 10 acres of land at some odd price and just let it sit there. I mean, you're supposed to do something with that land, because
So we definitely want to think of basically the uses that are available. So this could be, though, hunting, right? Crop. And then we talked about developing. So some of these issues are related to a little bit on soil condition, location, but all of that stuff, what would be the uses of the land? Some of that might be restricted by the city codes or governments. So what we call zoning, which we'll spend more time on later, but the zoning of the land by government. You might not be able to put up a trailer court there. You might not be able to put up a nuclear power plant there or whatever. So they can have different zoning uses. Okay, so lots of different things can contribute. And so at a very, very basic level, it's, I think, similar to what Andrew was describing, is that how much money are you going to generate off of the land if you were to treat it like an investment? How much money? So it could be a farmer who's buying the land to then put their own crops on, or it could be an investor that they own stocks and bonds, they own classic cars, and now they want to own some land. So they buy some land in Iowa and they rent it out to some farmer, right? And how much is the farmer willing to pay in rent? It depends on the soil condition, how fertile it is, blah, blah, blah. So all this stuff with either land rent and or purchase prices is going to be related to streams of payment of how much money you can make over time. All right, questions or comments there? Yeah.
Does the wage, the government policies affect
It could. So Carlos's question was, does the wage or government policies affect it? This is one government policy here, but if there was wages, let's just say minimum wage for instance, if we have a production process like harvesting crops that's heavy in labor, then yeah, it would make a difference, right? So if we looked at state to state comparison, let's say one state has a $15 minimum wage and another state just has the current $7.25. If the market rate is $8 in one state and it has to be 15 in another, then to farm in this land would be more expensive with the $15, right? So that would affect the process. But now, so what would that affect to the ability of the farmer to pay rent to the landowner? Would it go up or down if the government has this high minimum wage or restriction? Would it go up or down in terms of the farmer? The farmer's trying to choose, let's just pick on Kansas and Missouri since we're here. So Missouri has a $15 minimum wage, Kansas doesn't. So if you're a farmer and all of the things are held constant, where would you be able to pay more for land rent, in theory, in Kansas or in Missouri where the $15 minimum wage is? In Kansas. There's a little more room. So in your production process, I know that can sometimes be counterintuitive, but over in Missouri where labor's more expensive, then I'm going to have less left over to be able to pay, because with economic profits being zero, right, I only have a certain amount. I have a little less left over to pay, so I, as the farmer, am saying, oh, well, I could afford to pay more rent here, which would be a better deal if prices were the same, right? So that's actually going to get us to, I think, almost our next slide, called the leftover principle. So what I just described to you is the way land gets determined. It's like the last thing in the process of, should I farm in Kansas or should I farm in Missouri? Well, let's take into account all the non-land costs, which would be wages on top of fertilizer, on top of other things. Take all the non-land costs, And then whatever's left over is, in theory, the most I could pay for land rent. So give this one a read. So again, like we do in many times in economics, we're trying to think about where prices come from and what the conditions are. So with this type of analysis, we're just thinking myself as a profit maximizing farmer, where would I want to locate? What's the possibilities of how much I could pay? I know that my variable costs with growing crops are a lot of these non-land costs, and so then whatever's left over potentially gives me the amount that I could pay. So to kind of build on Andrew's comment, let's say that we've estimated you can do $1,000 per year indefinitely, right? So we're just gonna somewhat make an assumption, but we're not gonna have an ending point. So how much would you be willing to pay for 1 acre of land that you're gonna get $1,000 per year? So this is the general present value formula. I can't wait to walk around the room and see who can put that down on paper. Every finance student, every economics student, and every accounting student that's going to graduate from Ottawa University should be able to put the present value formula, at least in its general generic form. I will be coming around the room and see your work. Okay, so
This future value.
that would be the future value. And then you need to think about, we're gonna have $1,000 per year for the rest of eternity. So you don't have to show eternity, but I'd like you to show what that looks like after, let's say, at least 3 years, and then it'd be continue on once you get the pattern. All right, so what do you got? 1 acre, 1,000 present value. Now I know you're a little bit earlier in your career. Have you done the present value one? You might not. So same thing with you, Andrew. All right, it's gonna be a learning experience here. Okay. Oh, okay. Yeah. So yeah, don't rely too much on that. Actually, okay. I was gonna say because that actually is different than what I'm doing here. We'll get to kind of the way they approach it. Okay, so from Lynn's spot, yeah, Lynn likes to use the tables. Yes, her and I have a fundamental disagreement on that. So she likes to use the tables. I like you to know the formula. Both of them work the same. All right, so Kaylin's looking pretty good, and McKenna. So did Kaylin copy McKenna, or did McKenna copy Kaylin, or did you both independently arrive at the right? Okay, you're on Lynn's table too. Yeah, you're a little earlier in there. Okay, so I see. You got the dot. Oh, you didn't have that. So that's Kaylin's is actually right. I thought you guys had the same thing, but you were a little bit different. Okay. All right, so let's get this down.
You were saying that these, you don't like these?
I don't like this. Yeah.
Why?
Well, I'll show you. All right, so.
But actually it worked, right?
Well, that's how the table. Jonathan, are you doing handwriting? Let me see what you got. Ooh, wait, a little bit further back. I can't see it. Okay. That's a good start. Yeah, your top one is actually better in some ways, but yeah, we'll work on that. Okay, so here's the thing. I'm not going to give you the principles version of the present value. You know what? I take that back. Since you guys... since we have a couple people that didn't get the Russ version yet, repetition is always good. So if I have $100 and I get 10% on my money, how much do I have next year? 110. So it's 100 times 1 plus 10% equals 110. What if I let it ride one more year and I get 10%? What's it worth after the second year?
121.
121. So compound interest is 110. So we're really taking 110 times the 1 plus 10% again. And I'm getting my $11 worth of interest, which gives me 121. And then here's the secret sauce. This sucker is this sucker, and this sucker equals this sucker. So let's put this sucker in for that sucker. And if you do that, you get 100 times 1 plus 10%. So now I've done this part of it, right? Which is upstairs here, times 1 plus 10% equals 121. Everybody with me there? This is the coolest thing that I invented, by the way. I think this is one of my more fun things that I like to do. So some of you have seen this probably for the third time already. How do I simplify this equation?
Into the, or to the second bracket.
Yep, it's squared, so 1 plus 10% raised to the 2 power. And now you've pretty much just derived the fundamental formula of finance, the present value formula. So the present value of 100 times 1 plus the interest rate raised to the number of time periods that you're compounding equals the future value. Or the present value, today's value, you take the future value divided by 1 plus the interest rate raised to the n power. That is the equation I feel every Auto University finance, accounting, and economics, for sure, I think all business students in general should have it. That is the present value formula.
Both are the
Okay.
same, like both are like.
Well, you're just going, yeah, this basically, this is the formula to calculate what my money's worth in the future. But this one is saying, I'm going to get future money, what's it worth today?
Okay.
Right? But it's the same thing. We just used a little algebra to switch it around. Andrew?
So ignore the formula in the book then.
Well, no, I'm going to get to that. The formula of the book has meaning too. But the author kind of does a little, let's just call it a shortcut, which is a good shortcut, but I don't think he really explains itself. Okay, any other questions on that so far? Now, what is going on with this one? How do we treat $1,000 each time frame? Kaylin was the only one I saw with the right answer, unless somebody modified their paper. So Kaylin, verbalize for me what you said. You are absolutely correct with what you had written.
So the present value equals future value over 1 plus interest rate to the first power plus future value over 1 plus the interest rate squared plus dot 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 plus future value over 1 plus the interest rate to the n.
Okay. So, does the future value have to be the same in each time period?
No.
Carlos is pretty strong there with no. What do you say, Kaylin? Not necessarily to this particular problem, but does it have to be the same in each time period? In general, no. Carlos is right. It could be $1,000 a year from now, $2,000 a year from now. So this is the general formula for n time periods. Now the key is that each future value has to be treated just like this. That's the thing that's a little bit hard, is that $100 5 years from now is a lot different than $100 2 years from now, right? So each time period has to be treated independently and summed together. All right, so what I'd like to modify, a friendly modification to Kaylin's, is put future value 1, future value 2, future value n. So those future values could be something different. For this particular problem, the way it's identified is that this is going on forever. All right, so this is, in general, the present value of a future income stream of FV1, FV2, and FV, and we should say dot, 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 FVN. And N can be whatever, some defined time period in the future. So note, N is some ending time in the future, which is not what we have going on here. This is indefinitely, so it doesn't end in the future sometime. So for this problem, it would be dot, dot, dot with no N at the end. We usually go F1, F2, maybe F3, and then dot, dot, dot forever. Then that brings us to Andrew's question. If it's forever, it turns out that there's a super smart mathematical genius type of person that boiled down that special case to a very simple formula that your authors used in the book. And so it's a simplification based on what's called a perpetuity. So, special case. A perpetuity of a fixed amount indefinitely. And I guess since we've come this far and we're being kind of geeky, or at least I'm being geeky, maybe you guys aren't being geeky, you know, it would be future value. This time, since it's a fixed amount, we could do future value divided by the 1 plus I raised to the 1 power plus the future value of the 1 plus I raised to the 2 power. Future value, I'm going to do one more, I think is what's normal for math, if I remember right. Plus dot, dot, dot. So it never stops. This is a special case. Dot, dot, dot. It never stops at time period N. It just keeps on going and going and going forever. So that's the perpetuity. That's the name it gets. And then, lucky for you,
That's it for more in the book.
this unending sequence of numbers. What?
That's it for more that is in the book.
Yeah, so this is no, this is not the formula that's in the book.
Oh.
The next one, I'll tell you the one that's going to be in the book.
Alright.
You're going to like it. So, for a perpetuity, math proof makes this sequence present value equals, this is the beauty, future value divided by I. I'll let you guys Google off class time on your own that there's a bunch of somewhat sophisticated math theory that boils this equation that goes on for infinity into this nice simple equation. Okay, why do I take the time to do all that? Well, a lot of times you need to use the real one to calculate values of things. And so this is you'll see me ask some questions where this is the bare bones basics of it. And then the book, it turns out, if you think about it this way, which was pretty restrictive, right? You're going to get $1,000 forever, but it turns out to have this nice property that it equals this. So, $1,000 indefinitely. So, for example, if your opportunity cost of I, your interest rate, your opportunity cost is 10%, what is the present value if the future value each year equals 1,000, which is now picking up where we left off right here. What's the answer? 100. 100 what? $100.
I have 10,000.
Not liking that. 10,000.
That's what I mean.
That's what you meant. Okay,
Yeah.
quick correction. So, yes, Jacob apparently took the 10, but remember when we have the percentage, we do need to change it to a fraction, so it's 0.1. So the present value equals the 1,000 divided by 0.1, which is 1/10, which gives you $10,000. So if your opportunity cost is 10%, it says that $1,000 forever is worth $10,000 to you. Now that almost sounds crazy, doesn't it?
Yeah.
Doesn't it sound too crazy low? I mean, think about it, $1,000 forever. Forever's a long time, right? I mean, I don't know about you, but when I think about forever, if we're thinking about God and eternity and stuff, it's like a million years from now. Oh wait, no it's not. It's like a million times 100 years from now. No, it's not. It's like a zillion years from now. It's like, well, we can't even understand it, right? But for some reason, it's only worth $10,000. An eternity of $1,000 per year is worth $10,000 lousy dollars. Well, where does that come from? Take, you guys heard about 30-year mortgages? Even though Dave Ramsey and myself doesn't recommend it, I agree with a 15-year mortgage. But just for fun, why don't you figure out, what is this number at 30? Pull out your calculators. 1 plus 0.1 is 1.1, so it's 1.1 raised to the 30 power. 1.1 raised to the 30 power. You know, what is that $1,000 payment 30 years from now worth? So the present value of the 30th year, the 30th payment, would be 1,000 over 1 plus 0.1, which is 1.1 raised to the 30 power. What is $1,000 30 years from now worth if your opportunity cost is 10%? 57 bucks. Couple people got 57. Couple more nods. 57 bucks. And so that's where we start to get the present value really kicking in. $1,000 is only worth 57 because it's 30 years from now. And then of course if you do 45 years from now or 50 years or 1,000 years from now, it's worth a couple pennies, right?
So when comes up?
So what's what?
So why it's 10,000 for a million?
So basically this is one of those, so then you'd add up, do 1,000 of them. You could do an Excel spreadsheet. Sometimes classes have exercises like that. I'm not going to do it, but if you wanted to create an Excel spreadsheet and do it 1,000, you're going to get down to pennies after, I think, around 45, 60 years. It gets down next to nothing. So I guess since Carlos brought it up, what's the present value of the first year? What's $1,000 worth after 1 year? Like next year I'm going to give you 1,000. What's that worth? 909. So we've already lost $100 after the first thing. So what this sequence says is it would be 909 plus something less, something less, something less, something less, until you get down to the 60th year and it's worth a penny. And all you're doing is you're adding up all these numbers, and what they're saying is that's going to approach $10,000. See the connection?
Yeah.
Is everybody with me? Any questions? So this ends up being kind of a simplification. Now, in the real estate business, it's an important simplification called the capitalization rate too. So that's another thing I'd like to, since we're doing this pretty detailed now, I think there's other parts of this book and certainly other books where you talk about the cap rate, the capitalization rate. So note, this is related, or basically the same, as or to the capitalization rate. So those of you who took investment finance, we talked about this for sure, the capitalization rate. Some of you haven't had that yet. So affectionately known as the cap rate. So in the real estate business, when I was selling investment property, people would say, well, what's the cap rate? What's the cap rate? And so pretty soon, when you have a piece of investment property that's listed on the market by a realtor, the cap rate is one of the figures that are shown. Turns out the cap rate's not a very good statistic to show. In general, it does a little bit, but it doesn't do a lot. But it does help you compare property to property, but you have to really dig into the assumptions of where they're getting that from. And so here's the cap rate. Let me just let me do this and then I'll come back to your question. So we already said the present value which would be the price today. The price today is equal to the income stream over time. So if I own a rental property, it would be the money that I'm getting after my tenants pay their rent and I pay my taxes, right? It's some sort of profit per year income stream, or this could be the profit per year, divided by the interest rate, which is now going to be referred to as the cap rate of I. Okay, now let me do a little wiggling here. The cap rate for a property could be looked at as the income stream divided by the asking price or the price that you're willing to offer. So that's where it comes into use with real estate. And some of you might take a real estate finance course I think is going to be offered again at some point. So the income stream, so let's say the buyer is off asking $100,000 for a property, and the property is paying $12,000. So the asking price for the duplex is $100,000, and the income stream is $12,000 per year. Tenants paying their rent, expected vacancy, taxes, insurance, all of that. Your profit per year is 12. What is the cap rate for this duplex? 12%. See how that's kind of nice to, you just have a, now I'm a buyer looking at 10 different duplexes, and I'm looking at their asking price, and they're like, oh, this one has a cap rate of 12%. This one has a cap rate of 5%. This one has a cap rate of whatever. So it kind of helps you kind of weed through data, but it's just a statistic. But it's very much related to what's going on here and what's going on in this chapter with valuing land over time. Okay, Carlos, did you still have a question?
That's the same on return on investment or not really?
It's one rate of return. It's one way to look at it. It's different than the internal rate of return, which might be, then we're getting back to the more sophisticated formula. But this is kind of a simple rule of thumb, right? It's one way to calculate a rate, but it's called the cap rate in the real estate biz.
So a higher cap rate is kind of like a better investment, you'd say?
Yeah, so how would the cap rate get higher? There would be more money per month. Or if I can talk this buyer down from 100,000 to 90,000, it basically helped me out as an investor. Yeah, 12 is pretty good. I actually would like to get a little better, but we'll have that discussion a different time. So here is the way the book presents it here, which is what you've got in your notes now, basically. So R is that land rent, to kind of tie this back to land rent. So R is the land rent. It's in the value in perpetuity. And then it shows you the maximum amount you'd be willing to pay for the rent. Hopefully you can pay less, but that would be the maximum amount. Okay, questions or comments there? Clarifications? That was actually a lot more detail than I was planning to go into, but it's so much fun. At least for me. I hope it's for you too. I might stick around with that. All right, good? Jonathan, good with you? Thumbs up? All right. So here we go. We got two pieces of land. One of them's got medium fertility. The other one's highly fertile, all right, in terms of how many crops, how many bushels per acre, or whatever the case is. So think about the farmer calculating their profits with all the other non-land stuff. And we get to this point where at this ground, I would make this much profit. And with the fertile ground, my costs are less. I have to spend less on fertilizer, maybe less on other things because the ground is so good. And so that would leave that as my potential profit. So of course, what's the farmer's gonna do? I'm going here. But everybody would want to go there. So what happens to the price of land when it's put out for bid? It goes up. And so it's going to tend to equalize over time, but it's helpful in thinking that if we leave out the land price, it gives us our maximum willingness to pay, right? So that amount of profit is the maximum willingness to pay for the land. Okay, questions on that one? Yeah, Jameson.
Would there be a point that a farmer went to the right side with the right graph?
Yes, in fact, we would expect them to be equalized. So over time, if it started to shrink up, if prices went so high, then you'd flip back over to here,
Okay.
right? And then you'd start to bid this price up, and then you go back over here. In a competitive market, what do we expect economic profits to be? Zippo. So all of this profit's going to go away. Remember that we were leaving out the land price in the beginning, so we're just trying to estimate the maximum willingness to pay. But the same is true over here. This represents the maximum willingness to pay here. Okay, anybody else? All right, so here's some of our assumptions that we've already covered a little bit of where this comes from with this leftover principle. So perfect competition, economic profits equals 0. Farmers are going to be price takers and all that stuff. It also assumes that the non-land stuff is equal for the farmers in the high fertility area and the low fertility area and the medium fertility area, right? Just one of the assumptions that we're not going to allow Kansas and Missouri labor to be differentially priced. All of that stuff's going to be equal for the model. Land goes to the highest bidder. Landowners will actually rent to the highest bidder. Of course, in the real world, you might say, I know that rich Donald Trump's coming to town trying to buy up all the land, but Jacob, you and I have known each other for years. I'm going to sell it to you at less than what Donnie Trump's going to pay for it, right? So that could be the real world, but again, in our economic model, we're going to ignore any cronyism, as the case may be, or whatever, buddy system or non-monetary benefits flowing one way or the other. So 0 transport costs, so no martini glass. We're just going to assume that we've got the matter transmitter or something, right? So we're just going to assume that away. And then national prices. So we've got a bunch of, a big market, basically. Okay. So we get this leftover with the willingness to pay. There's it in a formula. Total revenue minus non-land cost gives you the total amount. Ultimately, we'll be putting the land cost in too, but to kind of conceptualize this leftover concept, what is our willingness to pay? Now, I don't know if the author changed this or not. I don't think they did. But a hectare is, you can just think of like an acre, but it's in the metric system. So an acre of land has different dimensions, but it's similar to an acre. You're not going to have to know the difference. So if you see the word hectare, just you can tell yourself acre or whatever. So that's hectare. Well, you probably do hectares in Colombia, right? Yeah. I mean, I think everywhere else in the world is probably hectares for the most. I don't know if there's anybody that uses acres, because us Americans wanted to be different, and we're gonna have a different measuring system even. That's how unique we are. So we went against the world with the metric system, which I don't think was the best idea in the world, because the metric system's a lot easier, all in multiples of 10, rather than 12 inches and 16 and whatever, all the different conversions. Okay, fine. So we can look at it from a schedule of numbers, taking the price of corn, and we're going to do 20 units, so we get total revenue of 20. My non-land cost of 15, that means I've got $5 left over for the land, right? So it's the maximum willingness to pay. The high fertility ground gives me double the amount of output, double the productivity, and so I can be willing to pay up to $25. All right, good with that one? Just kind of looking at it in different forms, saying the same thing. So we do expand or relax that assumption of location and transportation cost eventually. So what drives the price of land if driving is a significant cost to your business? What happens if driving is important cost of your business? What's going to be a big thing if you're literally driving maybe semis or cars or delivery trucks, or what else is going to be, Julian? Roads are going to be significant, right, and important. So that's going to play into our overall equation once we relax that. So what's our freight costs going to be? So this is kind of similar to what we did with bringing in some transaction costs. So we got our total revenue, but now we've got distance to maybe a freeway or something. And so we've got the non-land production cost, the freight cost, and the willingness to pay for the land now is going to be less when we're further away from the freeway or further away from the port, or however we're telling the story. And so now the bid rent for the land with zero transportation cost is 60, but the further away we are, it declines according to our distance. So now we're basically back into martini glass world, right? Where we have some distance that we have to account for. Okay, 10-second pause to have you think about things. Any questions?
Are there any other non-land production costs you can think of?
I mean, these are the ones we're focusing in on because of location being important. So either some sort of access, so anything involved with location. If you we're talking more about a manufacturing here, but if you were retail, then it might be proximity to your customers, and we'd be back to some of those other models that we talked about with how much the cost to the customer is if they have to drive to get to us. So that would be something else, but that's not being shown here. All right, so this ends up creating a bid rent curve. It's kind of a demand curve, but we call it a bid rent curve. Why? Because we're looking at distance here from the highway and how much you'd be able to do. So this is essentially the side of a martini glass, right? So as I move further away from zero, I have to start incurring these driving costs. And that causes me thinking about the leftover principle of whatever's left over is what I can afford to pay for rent. Now we've got kind of the martini glass going on, and eventually that land doesn't make sense to me anymore. If it's so far away, my driving cost ends up outweighing whatever the price of the land is. It's like, I'm going to find another location. So it's kind of like the demand curve. So it's very similar, but it's based off of distance again.
The vertical is what? How much? The price of the.
Yeah, it's if we're talking about renting land, so it's renting land, it could be buying land, right? Depending on if you're talking about renting or acquiring land for prices. The price thing would be kind of similar as well. But here we're thinking about renting the land, and the further I am away from the freeway, this is distance from the freeway, then the less I can afford to pay for the land. So yeah, the vertical axis is the land rent. Okay, any other questions or comments? All right. So with manufacturing, we have some of the similar things we've done before fixed input and output quantities. So that was kind of that fixed proportions that we've seen in other problems. Each firm produces a fixed quantity of bicycles with a fixed quantity of input. So I use 80 people and 20 machines to make 100 bicycles. That means that fraction always stays the same. If I double my bicycles, I'm just going to double from 80 to 160 for labor and from 20 to 40 for the capital. So it's always a fixed proportions. So this, again, this is just an assumption that can be relaxed later with substitution. Okay, fixed input and output prices. So I sell my bicycles for a certain amount, and the prices of all the things that go into making the bicycle stay fixed. Like no economies of scale or nothing with volume discounts. So everything kind of remains fixed. A central freight terminal. Firms import intermediate inputs from other cities and export bicycles to other cities through a central freight terminal port. So we got one port that we're kind of bringing in materials and getting our output out. Stop me along the way if you got any questions. Intra-city freight. So if the freight cost per kilometer is F equals 10, if a firm moves 1 kilometer farther from the center, its freight cost goes up by 10. Side of martini glass, right? So it's a fixed intracity freight from that spot. And then finally, labor cost decreases at the center. So the wage paid to workers compensates for commuting costs. The people who live at the center from our other models, we don't have to pay as much. And so that's what causes our central business district to grow, or one of the contributing causes to it. All right, questions or comments on those? Here we go. Remember this model. I'm talking about this one over here. Weight gainers, weight losers. Does that look familiar from maybe the tests last week? So where are we going to locate? Are we going to be at the center? We're going to be out. Relationship between labor, freight, and intermediate. So now we've added on some details here. So your cost function has now freight cost, labor cost, and intermediate input cost. That was assumed to be fixed. That's why it's a flat line. So it doesn't matter where we're at. So at this distance from the center at 4, it's this amount of money, 10, plus whatever this is, 25, plus my freight cost gives me my total cost of that amount if I'm 4 from the center. So taking all that into account, we can convert the leftover, using the leftover principle, how much could I pay for land? And so again, the further the distance from the center gives you more. At 1, that distance was 36 total revenue, which was flat across the board for our bicycles, minus the total cost, taking into account all these factors, gives me $36 that I could pay for a location that is 1 kilometer from the center. Ten-second pause for questions. Okay, so now the total cost and lot size, just remember that you can take the right-hand side of the equation, divide the right-hand side by t to get yourself the bid itself, how much the bid is each time. So in terms of calculating what that amount is, depending on the information that's given to you. So here, The rate times the total gives you the full equation, and so if we take everything on the right-hand side, we'll do a problem that'll be kind of similar to that to kind of solve the bid rent for each acre. Okay, there it is, or there's part of the slope here, piecing this together. So I'm saying 12 is the slope because I did a 1 unit change, right? So we did a 1 unit change. If we go from rise over run down 36, if we go from here to 12, so we're down 24 over 1, 2, 3, 4, and that'll give us the slope of the bid rent function. This is just ways that we're going to be able to look at changes when we do a problem. So this is kind of the anatomy of the bid rent curve. Okay. Okay, so when is price going to change? Well, according to the distance from these other factors, we're going to get to the zero economic profit is always our anchoring point, and then we can solve for what would be the proper bid rent at each one. So here's a little question for you. How does the business keep the landlord from capturing all of that economic profit? So if you've been with me so far, remember we're doing the leftover principle, and there's economic profit. Of course, I'm a profit maximizing farmer. I'd like to keep that for myself, but we're kind of indicating that the landlord, the landowner, might be able to capture that because they're willing to pay up to it. So kind of real world a little bit here. I just want to make sure we don't stick to the economic model all the time. What would keep them from capturing all of the profit?
Is this a legal thing?
What do you mean the legal thing?
Like, do they have laws or regulations against this?
No, that's we wouldn't. You're right. There could be some sort of thing with colluding or something. But here, what I'm trying to think of is we've got two people on opposing sides of the fence, right? I'm a farmer. I want to rent that land for as cheap as possible. I'm the landlord. I want to charge you as high as possible for the rent. If I charge too high a rent, you won't stay in business, and I can't afford it, right? And so how do we, if there is a number that is the maximum amount, how do we keep the landlord from capturing all of that?
Give them a percentage of profits?
Okay, we could get into a profit sharing thing. What else? Because I'm thinking I'm the greedy landlord and I can just charge the maximum willingness you're willing to pay, but in reality that's not true. Is the landlord going to know the maximum willingness to pay?
Yeah, we can allow.
What else is true in the real world on risk bearing? Who's taking on the risk in this venture? The farmer or the landowner? The farmer is the one taking on the risk. So we have a rent that's a fixed cost that I'm going to charge, but in reality, the farmer's thinking, okay, I might have a bumper crop or weather conditions might be not so hot. So I'm actually taking on more risk. So on paper, we can calculate I'm willing to pay $1,000 per acre, but that works if that total revenue stays the same. If in reality I've got a 50-50 shot of a good crop, then I have to lower the rent to take into account that risk, right? So there's a little bit of risk stuff that, and the reason I bring this up is it doesn't get modeled here. Don't ever get too far detached from reality. Hopefully as you kind of mature through your econ classes, you start to appreciate that one is an economic model that hopefully gives us insights about reality, but it's not reality. Right? But hopefully we can get better at predictions of where do prices come from in the world, and we've got some better insights to that. Okay, any questions or comments there? All right, so here's another bid for land function. Kilometers from the center. Kind of a freeway effect here. So now we start to see why the bid for land function is kind of like a demand curve, but how many demand curves do we have that are upward sloping? 0 in theory, according to the law of demand. So it is the bid rent function. It could possibly go up depending on the circumstances. So why was it going up here? What is this saying? Forget about this question for now. What is this saying? Why is the bid rent function upward sloping here?
Because of the labor cost
Because of the labor cost. What's happening as we get further from the center?
goes down.
It's going down. So we've got cheaper labor cost here, and the freight cost is going up real gradually. If the freight cost would have been a steeper slope, then we would have had just the opposite going on, right? So depending on the interrelation between how labor cost changes according from distance from the center and how freight cost changes, that's going to make a difference. And so what I say about the freeway effect is that if a brand new freeway, let's say we had those of you who lived in Lawrence, which is probably only Lawrence and maybe Kalen and McKenna.
What's your next pillow? Why do we make our pillow the shape of a cube? I'll tell you.
Oh, for
That's
goodness.
an extra credit though.
Looks like extra credit today. Hey. This is the cube pillow, which I don't know how it even searched that. That was nothing. Oh my gosh, I got a whole bunch of things open. All right. I think it was that cube pillow that you throw as a microphone and you throw it across the room or something. But all right. Sorry for that rude interruption. So we can go ahead, pull out. So I don't forget, pull out a piece of paper. Do Rust Busted. You can share. Do 2 separate pieces of paper, but you can rip it in half if you want. Jonathan, go ahead and email me a little Rust Busted.
You got it, shit. We're here, man.
Okay, so back to before I was so rudely interrupted by my own phone. When you go to Lawrence, it used to be a 2-lane highway. 68 was a 2-lane highway going up to Lawrence, and now if you've gone up to Lawrence, it's a 4-lane or 6-lane in places, but whatever, 2-way each way. And so, what happened to the freight cost function between Lawrence and Ottawa? Did it flatten or did it get steeper? It flattened, right? So the amount of time that you're on the freeway and all of that stuff. And so that's what this freeway effect thing is, that as a city develops and has maybe better infrastructure, it might have an impact on land in the city as well. So that's kind of this freeway effect. So here's kind of a different model based on where the freeway is. So if you're near the freeway and the freight cost is important, land by the freeway you could pay a lot of money for. As you move away from the freeway, then your amount that you can pay goes down. So this is another bid rent function that's kinky. You guys didn't think we were going to get kinky in here today, did you? So we are. Here it is. There's the kink right at point B. This is the location of the freeway. And then also that something that can play into the rent. Instead of getting further from the freeway, what's going on here? It's another kink. What is it? Back road, kinda, in a sense. Bid port. What do you think they're getting at there? So everybody with me? This is the location of I-35, if we're talking about Ottawa here. And then here's east of Highway 35, and here's west of 35. And then the author's saying that the bid rent function for the highway looks like this, but then we got this port thing, so somebody located here, and let me pick here just because we got this little differential here. What's going on with this sucker?
Intermediate inputs.
Yeah, so we had maybe intermediate inputs or other outputs, so the port was used to get our output out, is what I was bringing up before, where your consumers or your ability to get your product out. So now at this port, it's not just all about the distance from the freeway, but we have this other competing factor of another mode of transportation that's related to your business. And that would be the port could offset the fact that you're far away from the freeway, but you're closer to the port, right? And so now that might factor in. Okay, questions on that picture? Main thing is you got the freeway, but I got some really cool pictures to get to. Here they are. All right, so guess what that is depicting?
Is that a city?
It's a city, yes. And what are the peaks and differences there? This one we did earlier with maybe office space. I think we did a little bit earlier. We didn't look at these exact pictures maybe.
That line in the middle be the business or the center itself, and then around that be where people are living or commuting from.
Okay, so what's the ring around the city? What's that peak going all the way in a circle?
Public transportation.
Nope,
Farthest we located on the highway?
it's the highway. So think about Kansas City or where you guys are from. Almost every city is this way. You've got 435 and 635 that run around the city, right? So in Kansas City, if you're familiar with that, you've got one road like I-35 going, and then you've got the ring around the city, which is 435, and then you can get other rings. So sometimes cities have two highway systems. Like if you go look at Dallas or something, a little bit bigger city, you might have a couple of those rings that are connecting places, or Houston probably be another good example of where you'd see that. And so what this is measuring is it's a three-dimensional look at the bid rent, the land prices. So the height that's extruded vertically in the three-dimensional graph is the amount of rent that's being paid. Closer to the freeway, it's higher rents, and then as you go away, it falls away. And there might be other factors going on as well. When we did the office rent or the buildings near the center, we had the central location theory with the big city. And so the rents are higher near the city, and then they fall away. And then as we add new freeway systems, it could start to get a little bit, more complicated as we go. So those are kind of fun. There's the combination, where we start to put the freeways in the central business district, and then we can kind of think about this tapestry of rents that are very differential depending on where you're located in the city. Why is rent $500 a month here, and it's also $500 here, but here it's $400? Well, it's a combination of a lot of factors that may or may not be relevant to your particular business, by the way, right? In terms of whether you're doing manufacturing or whether you're doing consumer-related products. Okay, so those are kind of fun. This is actually from the old, I can't remember if he put these in the new edition, but I thought they were so cool with the old edition. I think he does a little bit of it, but he doesn't have quite as much.
He only puts one of them.
He just put one of them in there? Okay. All right, well, let's take a look at a problem. Chapter 10, yeah, there's the picture from the book, one of them. That's why I kind of like the evolution of it. And that was one of the other pictures that I didn't show, but kind of the ones we looked at before. All right, so let's look at the Gandhi principle. Number 2. You guys familiar with Gandhi? So there's a little bit of truth to this thing. I don't know how much is true, but in 1917, Gandhi settled a dispute between Indian farmers and the British landowners. So remember, the Brits took over India. It was one of the British colonies. Under a sharecropping, since Lawson brought up some sort of profit sharing type of thing, so sharecropping was kind of similar. Under sharecropping, each indigo farmer paid 15% of its harvest to the landowner. Indigo, by the way, is blue. So indigo is actually I don't know if it's a root or a plant that will, when it's boiled down, gives blue. So indigo is a plant that's used for, you can use it to stain cloth so that you turn white cotton into a blue shirt or something. All right, so when landowners heard about the development of synthetic indigo, so chemical indigo, they quickly sold the land to the farmers. So those nasty Brits sold the land to the farmers before the farmers heard about synthetic indigo. So you can see where this story's going. Classic tale of the rich aristocrats taking advantage of the poor subsistence farmers, right? So that's some of our unfortunate history in many different forms. So here we go. When the price of indigo dropped, the farmers who had purchased the land demanded their money back. As Gandhi's research assistant, that's you, your task is to compute the appropriate refund for the typical new owner. You can assume that the annual output is 100 units of indigo per hectare per acre. The initial price of indigo is 10. Farmers have bank accounts that earn 10% per year, opportunity cost. The non-land production cost per hectare is $850. So the sharecropping arrangement is consistent with the leftover principle because blah, blah, blah. So now you can kind of start to work on your own, see what you come up with. And you can talk to, I said work on your own, but I met with your buddies. Yeah.
We don't know how many the farmers pay for the land.
Well, everything's done in per acre per hectare, so you're using the leftover principle. You've got the non-land production cost, so you're going to kind of work it from there. just let me know if, I don't know if you guys have your books with you, but some of the story is on this page too, so. I guess we had most of it, but this part you need for the story was the 15%. Each indigo farmer paid 15% of the harvest to the landowner, was the sharecropping agreement. I don't hear a lot of talking. You guys all have this nailed all on your own.
I don't know for what. Which one? We must use the 15% for something, so.
What's that?
We must use the 15% for something.
Well, it's part of the calculation, you know, with the sharecropping.
Okay.
So that was their rent they were paying before, right? Was 15%. So it factors into the problem. So your homework is to do A and B. You can leave C. We'll work on that in class again, but A and B, I'd like to get A and B done here. After the synthetic indigo decreases the price, we're just basically calculating what the new real market value would be at 851. See you on Thursday. Yeah? Oh, the rust busted, yeah, turn those in up here when you're done. Jonathan, any questions? Okay, you good?